So as I said, we're going to do solving of trig equations, compound angles, and the double and half angle formulas. So begin. So solving of trig equations. Today I will focus much on examples because the basics of trigonometry, we did them in the last lesson that we had. So meaning today we're going to do a lot of solving. So for instance, when you're given such equations, when you've been given this, then you've been told to solve each of these same equations. And then what you are seeing here is a range. Sorry, this is a domain, yeah. Yeah, so this is a domain. This theta should not exceed 360. In other words, that's the way this means. So if you find any angle that is out of 360, you don't have to include it on your answers, on your final answers. So I think let us see how we can solve this first one here. So the first one is saying sine theta is equal to 0.5. We know to say 0.5 in other expressions, we can write it as half. So if you're solving such an equation, just say sine, you just say theta. In short, you're trying to find the value of theta. So theta is going to be sine inverse of this same half. Then we know by this time, and from what we learned in the previous lesson, on how to come up with the solutions of special angles. Sine inverse of half gives us a special angle, which is 30. So sine inverse of 0.5 is 30 degrees. So you don't end here. You don't end here. This is not your final answer. You have to check which quadrant does this theta lie. So when you look at this theta here, when you look at this this 0.5 which you've been given here, this 0.5, when you look at the 0.5 that has been given here, is a positive number. 0.5 is positive, and then we know to say sine is only positive in the first quadrant where all trig ratios are positive, and in the second quadrant. So meaning in the first quadrant, you take the value of theta to be the same 30. And then you check, is this 30 greater than 360? If it's not greater than 360, then it's part of our solutions. But if this 30 is greater than 360, you leave it out. So we have found one of our thetas, which is 30 degrees. And then we move on. In the second quadrant, you have your theta to be. So in your second quadrant, your theta is going to be 180. We know that in the second quadrant, there's this equation which is 180 minus x. And then our x in this form, in this question, is the same 30 that we found. So 180 minus 30, you get your answer to be 150 degrees. So this is your answer. So meaning on this question, you have two answers, 30 degrees and 150 degrees. When you try to put them where there's theta there, they will all give you this answer to be 0.5. Let us proceed. Same applies on the second question here. Cos theta is equal to that. So cos theta is equal to negative root 3 over 2. So when you want to find theta, you just say cos inverse of So cos inverse of root 3, you first have to ignore the negative. So it will be cos inverse of root 3 over 2. So you ignore the negative. So cos inverse of root 3 over 2, you get your answer to be, it should be 60. Cos inverse of root 3 over 2. Yeah, cos inverse of root 3 over 2 is, no, it's 30. Cos inverse of root 3 over 2 gives 30. Yeah. So this is 30 degrees. So once you get this 30 degrees, you now have to check the sign that is on what you are given this side. So the sign that we are given here was a negative. So here we have a negative, and then we know to say that when you draw this a quadrant plane, we know to say cos, here we have A, all soldiers take cover. So we know to say cos is only negative in the second and in the third quadrant. So to find the solutions, we're going to say theta in the second quadrant. So in the second quadrant, we're going to have our theta to be, we know that in the second quadrant there is this equation which is 180 minus the answer that we found, which is 30. So in the second quadrant, we're going to have our theta to be 150 degrees. And then in the third quadrant, so in the third quadrant, you're going to have your theta to be equal to 180 plus 30 degrees. That is going to be in your third quadrant. So your value of theta in your third quadrant is going to give you 210 degrees. So your final answers are 150 and 210 degrees. So this 30 is not part of your answer. Your answers are these. So you have also to check whether this 150 and this 210 are within the range that you've been given here, or within this domain here. So we move on. So for tan, we know to say tan inverse of theta, tan inverse of 1, you get, I think it's 45, tan inverse of 1. Yeah, you get 45. So you get 45 tan inverse of 1. So this 45, you have to check, is your theta going to be in the first or second or third or fourth quadrant? So we know to say tan is only positive in the first and in the third quadrant. So in the first quadrant, theta will still be the same 45 degrees. But in the third quadrant, theta is going to be 180 plus 45 degrees. So 180 plus 45 degrees. So 180 plus 45, you get your answer to be, so the value of theta is going to be 225 degrees. So these are your values of theta. So these equations are just as simple as this. When you talk about this cot now, so cotangent of theta is equal to the root of 3. What you have to remember is that cot is just nothing but 1 over tan. So 1 over tan theta is equal to the root of 3. So when you cross multiply here, you are going to have this tan will come this side, and then this root 3 will come this side. So we're going to have 1 over root 3 this side is equal to, this tan will go to the other side, which will be tan theta. So now, for you to find your theta, you are going to say tan inverse of 1 over root 3. And your answer will be 30 degrees. So tan inverse of 1 over root 3, you get your answer to be 30 degrees. So now, if your answer is 30 degrees, this is not your final answer. You have to check whether this root 3 which you've been given here is in the first or second or third or fourth quadrant. So we know to say tan is only positive because we know that this is positive. So we know that tan is only positive in the first and in the third quadrant. So in the first quadrant, you know to say theta is going to be the same 30 degrees. That is in the first quadrant. And then in the third quadrant, you're going to have your theta being equal to, so your theta is going to be equal to 180 plus 30. 180 degrees plus 30 degrees. So when you add the two, you're going to find your value of theta to be 210. So 210 is your solution, and this 30 is your solution. So there are some times maybe when you've been given this range, or maybe if this given domain here, I don't know why I keep on repeating range. Okay, if this given domain here is maybe from 0 less or equal to theta less or equal to 180 degrees. So if this was our domain, meaning this 210 is out of the domain that we've been given. So meaning it's not part of your answer. This simply means that all the answers that you are going to get are supposed to be between 0 and 180. But since the one that we've been given is this one, which is ranging from 0 degrees to 360 degrees, it simply means that 30 is between that 0 and 360, and 210 is between that 0 and 360, meaning they are all part of your answers. So solving these equations are simple as that. Let's move on. Let's see another dimension of such equations. So this one is question 11 from tutorial sheet 2. Yes. So how do you solve such equations? Simple. You also just have to take heart and simplify them before you even start getting your values of theta. So let's start with this first one here, A. So A, we are going to take this root 3 to the other side of the equal sign. So we're going to have 2 sine x. So 2 sine x is equal to negative of root 3. Then after that, you divide both sides by 2. And then you have your sine x to be equal to, so your sine x will be equal to negative root 3 over 2. So the best way you can handle such situation, you do this, you change, instead of putting x here, you say sine, you can use phi or you can use theta is equal to the positive of that. So negative root 3 over 2. So now find, oh sorry, the positive. You use now the positive of what you've been given here. So your theta will now be equal to, so sine inverse of that is 60. So sine inverse of that is 60 degrees. So this is not your final answer. You have to check where, in which quadrant does your answer lie. So now when checking the quadrant, you don't get this positive assumption that you had made here. You take your negative, you take the origin one, which is negative here. So you draw your quadrant plane like that. ASTC. And then you notice say sine is only negative in the third quadrant and in this, also in the third quadrant, yeah, and in the fourth quadrant. So you say in the third, so in the third quadrant, you have your x. You are finding x and not theta. Theta was positive here. So you have your x to be equal to 180 plus 60. So in the third quadrant, you are going to have your x to be equal to 180 plus 60. And then your x is going to be 240. So this is one of your answers. You also check it out. Is it within the domain that you've been given? If yes, then it's part of your answer. Then you move to the fourth quadrant. So in the fourth quadrant, your x is going to be equal to 360 degrees, then minus 60 degrees. Then you find your x to be 300 degrees. All right, let me see, there's somebody raising up a hand. Okay. Let me just say. Aline, you have a question?
Yes, I do.
Yeah.
So what happens in the case where your final answer, like your theta, is out of the range? Because I remember in one of our tutorials, I don't know if it was Mr. Tembo, he said there was a way of bringing it down. I just don't recall which way that was. I'm not sure if it's for this type of scenario. Like, what happens if it's out of the range?
If you've been given this domain here, and then you discover that your answer is out of the range, then it's not part of your answer. You just leave it. You just leave it. So make sure that every time you finish solving the equations, you write your answers. Let's say, for instance, you say x, and therefore the value of x. You say therefore the value of x will be equal to, and then you list your answers here. So in this case, we're having the values of x to be 300 and 240, but I was supposed to start with the smallest number here. Yeah, you start with 240 and then you write your 300. 60 is not part of our answer. So that's what you do. So if there's any value of x that is out of the range, you don't write it. You don't put it on your final answers.
Mr. Teddy.
Okay.
Yeah.
Mr. Teddy.
Yes,
yeah.
Well, I think she's trying to talk about what's this, double angles.
Oh, double angle.
Yeah,
right.
Where a value exceeds 60.
Oh, yeah, we'll go there. We'll go there. We'll go there. I think if not in this lesson, then in the next one, but I'm sure it's in this lesson. We'll go there. I'll show you how to do it. All right. Continue. So these are your final answers. 300 and 240 degrees. You move on to the next one here. So tan squared theta is equal to 3. So we have tan squared This is tan squared x is equal to 3. So you know to say when you are finding this always moves with plus or minus. I've just remembered this, plus or minus, meaning our tan theta, our tan x is going to be positive or negative the root of 3. Yeah, I think I need also to go and correct this on the videos on YouTube. It has to be like this. And then when you're finding x, meaning when you're finding tan x, so tan x is going to be either the positive root 3 or tan x. So take note of this, tan x is equal to the negative of root 3. So you find the value of x when tan is positive root 3, and then you find the value of x when tan is negative root 3. Then you find the quadrants where they lie. So meaning when tan is, so for the first one there, so for the first one you find your x to be, you find your x to be, okay, for both you find your values of x to be tan inverse of root 3, that is 60. So you find your value of x to be 60 here. Even here you find your value, here you not find x, you find, since it's negative, you're going to find the theta to be 60 as well. But here the value of tan x here, the number that you have here is positive. So meaning tan is positive in the first and the third quadrant. So meaning you're going to find the value of x to be 60, meaning one of the answers that you're going to have is this same 60. And then in the third quadrant, you're going to have 180 plus 60. So meaning, let me write the values of x here, the final answers. It will also be part of your work. I just want to see whether you've understood or not. So this is going to be x is equal to, the first value of x that we're going to have is 60, because it's in the first quadrant. And then in the third quadrant there, you say 180 plus 60, where you're going to get your 240 degrees. Then you move on to this one. When theta is equal to 60, and then in the mind you know to say the tan of x was a negative number, and then tan is only negative in the second and in the fourth quadrant. So in the second quadrant, you're going to have your theta, your x to be 180. You're going to have your x to be 180 minus 180 minus 60, which will give you, is it 120? Yeah. And then apart from that, in the fourth quadrant, you're going to have your 360 minus 60, meaning you're going to have 300 as your answer. So you move on to the next question, which is 2 cos x, or 2 cos squared x is equal to cos x. You first take the cos to the other side of the equal sign, and then you factor out. When you factorize there, you're going to have cos x, and then open brackets, 2 cos x, you're going to have 2 cos x minus 1 is equal to 0. And then from there, you can now equate that cos x to 0, and then you also equate 2 cos x minus 1 to 0. So cos x is equal to 0, and also 2 cos x minus 1 is equal to 0. So after that, you can take now cos x. So we say taking cos x is equal to 0, you have x to be equal to cos inverse of 0. So we know to say the cos inverse of 0 is nothing but 90. So here your value of x, you have it to be 90 degrees. So you found one value of x. So you can try it out to say, what if you can try it out by finding the quadrants. Say in the first quadrant, all are positive, and then we know to say cos is positive in the first quadrant, and then it is also positive in the third quadrant. So you can try it out. You still, yeah, it is also positive in the third quadrant. So in the third quadrant, in the first quadrant, you get this same answer, your 90, as your final answer. And then in the fourth quadrant here, so I said the third quadrant, the fourth quadrant, your x is going to be equal to 360 degrees minus 90, which gives you 270. So your other answer that you're going to have is 270 degrees. So after finding this, you also take this one here, because we have just finished finding the first part, which is this side. We've only answered this side. Let us also now answer this part, this side. So when you take this negative 1, you take it to the other side of the equal sign there, you're going to have something like this. You're going to have 2 cos x is equal to the positive 1. Then you're going to say cos x. When you divide both sides by 2, you're going to have cos x is equal to 1 over 2. And then your value of x is going to be the cos inverse of 0.5 is equal to 60 degrees. So cos inverse of 0.5, you get your 60 degrees, like that. So cos inverse of half is 60. You also have to check in which quadrant does this 60 lie. So when you check this side, you have a positive number, which implies that cos is in the first quadrant there and the fourth quadrant, because that's where it is only positive. So cos is only positive in the first and in the third, or in the fourth quadrant there. So in the first quadrant, you get the same value of x. But in the fourth quadrant, your x is going to be, so in the fourth quadrant, your x is going to be found by saying 360 degrees minus 60. Let me just check if I'm recording. All right, it is. So the value of x is going to give you 360 minus 60, you get your 300 there. So now, after finding all these values, you can now go on and say, my value of x is now equal to, you check, or you check on all the answers that you've gotten. Try to see which ones are in the range of 0 to 360, and then you write them as your answer there. So the smallest one that we have is 60 degrees, and then followed by 90 degrees, then followed by 270 degrees, and then finally you get your answer to be 300 degrees. So these are your answers. Let's quickly move on to the, I think I'll skip D. D will be one of your exercises, because D is a little bit similar to C. The process is not very much different. It's almost the same. And then let's try to solve E. So for E here, you have 2 cos squared x minus sine x minus 1 is equal to 0. So the first thing that you have to change here is this part here. And I'm pretty sure that most of you know this identity, which is, so this identity, which is sine squared, so sine squared x plus cos squared x is equal to 1, this one here. So here, we have to change one of these into the other trig ratio. So I'm going to make cos squared x in this equation to be the subject. So cos squared x, so cos squared x is going to be 1 minus, you just take this sign this side to be negative sine squared x. So where there is cos squared x in this expression, I'm going to put 1 minus sine squared x. So this is what I'm going to have. Where there is cos squared x, I'll put 1 minus sine squared x like that. And then minus sine x minus 1 is equal to 0. Then you just open the brackets here. 2 times 1, you are going to have your 2 there. And then 2 times negative sine x, you get your negative 2 sine x or sine squared x. And then minus sine x minus 1 is equal to 0. So from there, what you do is you pair the like terms. So you say this 2 minus 1, 2 minus 1, you get your 1, positive 1. So let me just write these first. So I'll write negative 2 sine squared x minus sine squared x, oh sorry, minus sine x, and then 2 minus 1, I'll get positive 1 is equal to 0. So what I can do here in order to simplify my work, I can divide everything by negative 1. Sorry, this is plus 1. So I can divide everything by negative 1. So when I divide everything here by negative 1, I'll get my answer to be 2 sine squared x. And then instead of being a negative here, to be a positive sine x. And then here, instead of being a positive, it to be negative 1, which is equal to 0. So once I have this, if you look at this properly, it's in the form of a quadratic equation. Now, for me to simplify my work, I'm going to equate sine x. So for me to simplify my work, I'm going to equate sine x to a certain variable. I'm going to say let sine x be equal to y. So while there's sine x in this, I'm going to put y. So I don't want to confuse myself when it comes to solving this equation. If you want, you can solve it the way it is, but it's better when you change it to at least something that you can even solve quickly, because writing sine x will spend more time than just writing y. So wherever there is sine x here, I'm going to put y. So this is y squared plus y, then minus 1 is equal to 0. So when you look at this, this is a pure quadratic equation. So from there, you can even find the factors and you find the product, the sum, and the factor. So here the product we have is negative 2, and then the sum is is positive 1. So we find two numbers that when we multiply them, they are going to give us, when we multiply these two numbers, they are going to give us the product, which is -2. And then when we add these two numbers, they are going to give us a positive 1. So the easiest way you can find this, if you have a problem or if you get challenges to find this, you just write your product. So your product is here, which is -1 times 2, you get your -2 as your product. So how else can you find this product? It's by multiplying 1 times -2. You can get your answer to be -2. Or if you want, you can multiply -2 times 1. So let us try to add these numbers. 1 plus -2, you get to -1 this side. -2, oh sorry, this, let me do this. This is supposed to be like that. So it's going to be like this. So 2 times -1, you also get your -2. Yeah. So let us try to add 2 plus -1, you get your positive 1. So you get a set of what numbers that is giving you the sum here. Then the sum here, which we have, is positive 1. So positive 1 is the sum that we have. So which set of numbers is giving us positive 1 here? Of course, it's this one. Yeah. This one is giving us positive 1. So this one is giving us positive 1. So we're going to get this set of numbers. So I'm going to put them there. This is 2y squared. And then we have positive 2y. And then -1. Then -1 is equal to 0. So you just have to factorize there, which is 2y is common. Then open brackets, you have y plus 1. Then this side, -1 is common. So if you factorize it, you're going to have y plus 1 in brackets. So when you're solving a quadratic equation and you find that what is in the brackets here is different, just know that you've made a mistake somewhere. Every time this is supposed to be the same. So y plus 1, so this is y, sorry. This is y plus 1 in brackets like that. And then this side you have your 2y minus 1. You also put it in brackets like that. So you now say either y is equal to 1 or either y is equal to -1. When you equate this to 0, you take the one to the other side of the equation, you get your y to be -1, or your 2y is equal to positive 1. And then when you divide both sides by 2, you get your answer to be 1/2. So we have our y to be -1, and then our y to be 1/2. So from there, you can now recall to say, at one point I said my sine x is equal to y. So meaning while there is y on these answers, I'm going to put sine x. So while there is y, I'm going to put sine x. So I'll take the first one here. While there is y, I'm putting sine x. So sine x is equal to -1. So for me to find the x, I should find the sine inverse of -1. But remember what I said, instead of you finding x, since the number here is negative, meaning you use some other variable here, don't use the same one which is there. So you say for you to find you just say theta, maybe you use theta, and then this one is positive. You say, so you find sine inverse of 1. So sine inverse of 1, you get your answer to be 90. So your theta is equal to 90. But remember, what we're finding is not theta. We're trying to look for x. And then we know that our sine x is negative. And then according to these quadrants, we know to say sine x is only positive, is only negative, since it's negative here, is only negative in the third and in the fourth quadrant. In the third and in the fourth quadrant. So in the third quadrant, sine x, in the third quadrant, the value of x is going to give us 300 and, sorry, not 306. In the third quadrant, the value of x is going to give us 180 minus 90, sorry, plus 90. So 180 plus 90, which gives you, is it 270? Yeah. So this is one of our values of x. And then in the fourth quadrant, you know to say your value of x is equal to 360 minus 90. So 360 minus 90, you get your value of x to be 270 again. Yeah, 270 degrees. So if you have the same answers, when writing the final answers, you just write it once. So we found our value of x to be 270. So let me write this here. But remember, we also have y is equal to half. And then remember, we said where there is y, you put sine x. So we're going to have sine x. Sine x is equal to half. Then to find the value of x, you find sine inverse of, this was supposed to be inverse of, you find sine inverse of half. So the value of x there is equal to sine inverse of half, you get your answer to be 30. And then since our sine x here is a positive number this side, so it simply means that sine is in the first and in the second quadrant. And then since sine is in the first and second quadrant, in the first quadrant, you just get this same value here. But in the third quadrant, in the second quadrant, you find your value of x to be 180 minus 30 degrees. So 180 minus 30, you get your value of x to be equal to 180 minus 30, you get 150 degrees. So this is your value of x, meaning the final answers for x, I'm going to write them here. So meaning, therefore, you say, therefore, my values of x are, you have the smallest one is 30, then followed by we have 150 degrees, and then you have 270 degrees. So I think you now get the point here. So this 270, since we found it at 2 points here, you don't have to repeat it again. Just write it. You don't have to repeat it. You just write it once like that. So we also have sec squared x, sec squared theta, minus 6 theta minus 2. So this one you just solve it the way I solved this one, e. But for sec, you know that sec is nothing but 1 over cos. So meaning you just change it like that. This 1 over cos squared theta minus 1 over cos theta, 1 over cos theta, then minus 2 is equal to 0. So this is what you're going to have. And then you just know how to manipulate this. So if you want this is just one way in which you can do it. You can multiply everything by cos squared x. When you multiply everything by cos squared x, you're going to have 1. This cos squared times that, you're going to have 1 minus. When you multiply this times that, you're going to have this cos squared theta, not x. You're going to have cos theta. When you multiply this, you're going to have negative 2 cos squared theta. And then when you multiply it with 0 there, you are going to get your 0. So from there, you just say let x. Since we are using theta here, you can even let it be equal to x. Let cos to be equal to x. So while there is cos theta, you will replace with x. Then you solve the quadratic equation and then find the final answers. So that's it about this question. Okay. So if you need the solutions for the above questions, you can visit that link. We move on to compound angles. So compound angles by definition are angles which are the algebraic sum of 2 or more angles. So meaning when you have, let's say, 30 plus 60, when you have something like cos 30 plus 60, this is one of the example of compound angles. This can also be written as cos 90. So cos 90 can, in other words, can be written as cos 60 plus 30. These are what are known as compound angles. So let's see. Yeah. So this is just a summary of compound angle formulas. You have sine A plus B to be equal to that. So for me, how I master these, because you need to know them by heart, they are not going to be given to you in the exam. So for me, the way I master this, when you look at this sine, if there's a plus here, there's also a plus there. If there's a minus there, there's also a minus there. Okay? But for cos, it's the opposite. If there's a plus there, there's a minus there. If there's a minus there, there's a plus there. So the way I master this myself, I'll say for sine, I will know to say sine. And then what you should also put in mind before I show you this is that every time if you have sine this side, the first trig ratio that we're going to have here is going to be sine. That is the way it is. If you have cos, the first trig ratio is going to be cos. So the way I master this when it comes to sines here, if I want to know where there's whether there's a minus, there's a plus. So for sine, I'll say sine. Let me write sine on top there. Sine, you are going to have the same sign between. So sine, you have the same sign. And then for cos, it's the opposite. So for sine, where there is if there's a plus here, even there you find the plus. If there's a minus there, you're going to have a minus there. All right, this is just for sine. For cos, it's just the opposite. of, it's just the opposite of sine. And then tan, when there's a plus there, you have a plus there. When you have minus there, you have a minus there. So let's proceed. So sometimes you can be given to solve equations to prove such identities as these. What you should also bear in mind is that the special angles are supposed to be on your fingertips. You need to know them. So for the first one here, you know to say sine x plus 90, x plus 90. They want you to show that this sine x plus 90 is just the same as cos x. So how do you do that? We know to say for sine, the first, if there is sine this side, the first trig ratio that I'm going to have here is sine. So it's going to be sine x, and then I'm going to have cos. I'm going to have cos 90. And then if there is plus here for sine, same sign. So I'm going to put a plus there. And then I'll write my sine this side. Sine. I'll switch the angles now. I'll put sine 90 there. And then I'll put cos x there. So you know to say sine x will just remain as sine x. I'm just remaining with about 8 minutes or so. So sine x, and then cos 90, you know that is 0. And then plus sine 90 is 1. And then cos x will remain as cos x, like that. So when you simplify this, you're going to have sine x times 0, you get your 0. And then plus cos x times 1, you get your cos x. So this is going to give us cos x as our final answer. 0 plus cos x, you get your cos x. Okay, we move on to the next one. But before we move on, let me first unmute you a bit, you guys. I just want to find out something. By the way, sorry for the inconveniences that we had. They are not intentional. Okay, so I want us first to discuss. Can we maybe add more 20 minutes? Because time is already up here. Can we add more 20 minutes where we just maybe try to finish up the slide? What's your advice, you guys?
Yes.
You can do that? All right.
Yes, we can.
Okay. All right, thank you very much. So I'm going to generate another link, which is just going to be for 20 minutes. All right, so we move on. I guess from the slides, from the previous slide here, just using what I'm just from showing you. Just using these, you can solve most of these questions here. I don't know if you can have any challenges on N, because it's just a matter of replacing just putting where there's it's just a matter of using these formulas here. You just have to know them by heart, so that when it comes to using them, you easily remember them. Yeah. So it's just a matter of using these formulas here, and then you replace where there's alpha, where there's a here, you put your alpha. Where there's tan b here, for instance, in this question, you put pi over 4. And then for these questions which are having pi, for these questions which are having angles in radians, if you're not if you're not able to use these angles in radians to solve questions, I would advise you, first of all, before you even start solving the question, you convert all the angles that you have in that question into degrees. when you convert them, and then when writing the final answers, you convert them back to radians. That applies for all the questions that you're going to be meeting. So for this pi, you know that pi is just nothing but 108. So pi is nothing but 108. So it's up to you if you want to use it as it is, as pi, or you use it as 108. Then pi over 4, you know to say it's nothing but 45 degrees. So this is alpha plus 45 degrees. Yeah, just as simple as that. Okay, let's move on. So yeah, I was trying to solve this first one here. You replace everything like that. Yeah, then you find your final answer to be cos x. So if you want the solutions again, you can visit that link there. So let us now try to solve these. So for these questions, before the time elapses, let me solve at least one. Let me start solving one, then we'll come and finish it up in the next session. So this is so given that sine alpha is equal to 3 over 5, and this sine alpha is in the first quadrant, and then sine beta is 15 over 17, with beta in the second quadrant. Then the question is, find tan alpha minus beta, and then tan alpha plus beta. So given this question, you first have to find what your, okay, let us draw the triangles. So my alpha is going to be here. Using the information that I've been given there, my alpha is in the first quadrant, and then it's going to be there. And then meaning sine, we all know to say sine is opposite over adjacent, over hypotenuse. So my opposite here is going to be 3, the opposite to this angle, and then my hypotenuse is going to be 5. So meaning this side I'm going to have, so 5 squared minus 3 squared, you are going to have 16, meaning this side I'm going to have my 4. Then since it's in the first quadrant, let me try to find tan now, because my question is saying tan alpha minus beta is what I'm supposed to find. So tan alpha from tan alpha is going to be equal to, so from this, tan alpha is going to be equal to, tan is adjacent is opposite over adjacent. So tan is going to be the opposite, which is 3, over the adjacent to this angle, which is 4, like that. So this is going to be my tan alpha. Then I'll also draw the triangle for beta, like that. The triangle for beta, they are saying beta is 15 over 17. Sine beta is 15 over 17. Then I know to say my sine is nothing but the opposite. So my opposite is 15 over hypotenuse, which is 7. Oh no, I wasn't recording. Anyway, I'll know what to do. So after doing this, you quickly now move on to writing the formula. So this question here, A, this question A there, I can write it in terms of alpha and beta, because I know that where there is tan inverse of 7/5, I'm going to replace with alpha. Where there is sine inverse of 4/5, I'm going to replace with beta. So this question is going to be like this. This is going to be cos. Where there is tan inverse of 7/5, I'm going to replace with alpha. Let me not write it here. There's something that I want to come and put there. So let me write it this side. So where there is, so I'm going to say cos. Where there is tan inverse of 7/24, I'm going to put alpha. And then where minus, this minus there. And then where there is sine inverse of 4/5, I'm going to put beta, like that. So I'm going to say this is equal to, I'll write the compound angle formula for this, which is cos alpha, and then cos beta. Then for cos, if there's a minus here we're going to have a plus. Plus sine alpha, sine beta. Sine alpha, sine beta. Like that. So when you have such now, you ask yourself, from the information that have been given here, do I have cos alpha and cos beta? Of course, no, I don't have. From the information that have been given here, do I have sine alpha and sine beta? I only have sine beta. I don't have sine alpha. So how do I find that? Remember what I was doing on question 8a. I'm going to draw a triangle here. And then this is going to be my alpha. Let me cut this here. So this is going to be my alpha. So if this is tan alpha, if this is tan alpha, it simply means that this is opposite over adjacent. So my opposite to this angle is 7. And then my adjacent to this angle is 24. So if I have 7 and 24 there, meaning my hypotenuse is going to be, my hypotenuse is going to be 25. When you use Pythagoras theorem, my hypotenuse is going to be 25 this side. So from this, I can now find cos alpha. I can also find sine alpha from this. Now, how do I do that? I have to look at this angle. Is it in the first quadrant? Is it in the second quadrant? Or is it in the third or fourth? I'll look at it, and when I see this, the information that I'm getting from this is that this angle is positive 1. This angle is positive, meaning it is in the first and the third. It's in the first and the third quadrant. Okay, yes, in the first and third quadrant. Now I'll take it that it's in the first quadrant because it's positive. Because if they wanted it to be in the third quadrant or any other quadrant, they would have specified maybe. But for such a question, I'll just take it as they are all in the first quadrant. Yeah, because it's not specified. So now, how do I find my sine alpha and my sine, my cos alpha from this? So sine alpha, I know to say sine is sine alpha is going to be equal to, I know to say sine is opposite over hypotenuse. So my opposite is 7, and then over hypotenuse, which is 25. We also have to find cos alpha because we have cos alpha in this compound angle formula, which we don't have in the question. So we also have to find cos alpha. So cos alpha is equal to, cos is adjacent, so my adjacent is 24 over hypotenuse, which is 25. Over my hypotenuse, which is 25. So it's 24 over 25. That is my cos alpha. Same applies to this. I'm going to write this, and then I'll put my beta there. Then given this, sine is equal to opposite over hypotenuse. So my hypotenuse there will be 5, and then my opposite there will be 4. Meaning the remaining part here, which is the adjacent, is going to be 3 when you use Pythagoras theorem. And then from there, we can now find, in this, for alpha, we already have sine alpha. What we don't have is sine beta. So meaning, what I'm going to find here is only sine beta. So let me find sine beta. So sine beta is, so sine beta is going to be equal to, sine beta has already been given. So what I'm finding is sine alpha. So sine alpha is equal to opposite, sine alpha, we've already found it here. Then sine beta is already there. Meaning what I'm finding is cos alpha, sorry for that. Cos beta. What I don't have now, because from this equation here, if you check, cos alpha, we've already found cos alpha. Cos beta is the one that we don't have. Cos sine alpha we have, and sine beta we have. So meaning we're finding cos beta. So cos beta is nothing but equal to, cos is adjacent, which is 3 over hypotenuse, which is 5. So now what we are just remaining with here is replacing these values in this equation. So our cos alpha there is 24 over 25. 24 over 25. You write it there. And then cos beta is nothing but 3 over 5. 3 over 5. You write it like that. And then plus sine alpha. Sine alpha is 7 over 25. And then you put it in brackets like that. And then we also find, we also replace sine beta. Sine beta we are already given, which is 4 over 5. So here what you are just remaining with is simplifying this. You multiply 3 times 24. I think this is 72, and then over, let me just write it quickly. 72 over 5 times 25, you get 125. Then plus 7 times 4, you get your 28 there, over 5 times 25, you get your 125. Then you add the 2, you discover that you're going to have your answer to be, is it 100? Does this give 100? Yeah, 100 over 125. This is the answer that you're going to have. So it's just a matter of reducing it. You find the number that can go into 100. 25 into 100, you get your answer to be 4, and then 25 into 125 over 5. Yeah, so you can try to put it on the calculator, you see your answer. Yeah. So this is how you solve such questions. Remember, I promised that it's just 20 minutes. I wanted us to go through these same questions, very important. Okay. So for this, let me just highlight something on this. And then I think for this, yeah, question 4 and question 18 here, they're almost the same questions. These are from your tutorial sheets, they are not different. And then we'll come and start double angles the next time we're going to meet. So let me just say something on this and then we end the lesson. So when you have sine 225, these are also compound angles. When you have sine 225, sine 225, so you find two special angles that you can add, to find to get 225. So sine 225 is just the same as sine. You can add 180. 180 is a special angle plus 45. When you add these two angles, you get 225 like that. So you get this when you add 45 times 180, you get that. 45 plus 180, you get that. So this now, you can use the compound angle formula, which is for sine, and then when there's a plus here for sine, there's going to also be a plus there, which says sine 180, and then this is going to be a plus, sine 180 multiplied by cos 45, this is 180, multiplied by cos 45, and then plus sine 45 multiplied by cos 180. Then it's just a matter of you now putting in the values. Sine 180 there, you find your answer to be 0 multiplied by cos 45. Cos 45 is a special angle there, 45, you can find it. And then you are done after simplifying. That's how you find such equation. So for 150, you can say 180 minus 30. 180 minus 30, you also resort now to the compound angle formulas, you get the answer. For tan 330, you can use 360 minus 30, you get 330. For sec 420, let me also say something about this. This should not confuse you. Sec is nothing but 1 over cos. So since it's sec 420, we're going to have 1 over cos 420. So if you want, you can first find the compound angle formula. Using the compound angle formula, the value of cos 420. So cos 420 is nothing but 360. So this is just the same as 1 over cos 360. When you add 360 plus 60, you get 420. So cos 420 is just the same as cos 360 plus 60. These are all special angles, and then you use the compound angle formula. Then after finding it, you come and divide it into 1. Then you find your final answer. Cosec 135, this is just the same as 1 over sine negative 135. So sine negative 135, how can you find the negative number? The negative number is found by subtracting the bigger number from a smaller number. So you find two special angles that you are going to subtract. So you are going to have 45. So let me just say sine. This is 1 over sine. So I'm going to get 45. And then I'll say 45 minus 180. When I subtract these two special angles, I'm going to get my final answer to be a negative 135. That's it. Then you use the compound angle formulas. And then for these which are in radians, you convert them to degrees and then use them. But if you want, you can use them as they are in radians. That is, if you are used to using radians. But it's better for you to convert them to degrees so that you know which ratio angles that you're going to use. Yeah, so that's it, I think, for today. Yeah, even this is just the same. Sine 15 is nothing but 45 minus 30. This is pi over 12. Pi over 12 is just the same as 15 as well. This is just the same as cos 15, which is 45 minus 30 as well. You also convert this into degrees and then find the compound angle formulas for that. You also convert this into degrees, you find the compound angle formulas for that. So thank you very much for you guys. See you in the next lesson that we're going to have on Friday. And I just pray that we finish trig on Friday. Because if we're going to do these half angles in the first session, meaning in the second session, we can do identities and also maybe start the graphing of trig, trig equations. We do some graphs. Once we do graphs, then we're done with trigonometry. So that maybe by next week, we just start complex numbers. So see you in the next lesson. I don't know if you guys have questions. Let me just unmute you all. If you have questions, you can ask. Do we have questions? Okay, I think we don't have questions. All right, then the meeting is ending. I'm ending the meeting. Yeah, I'm getting you.
Yeah, for the last second, can we just look like maybe the quadrant in which the angle is equal, for example, sine
Okay,
225.
let me just mute everyone. I'm not getting you. Let me mute everyone and then try to raise the hand there, and then I'll. Okay, and then raise your hand now. Okay.
Oh yeah, I was saying for question 4.
Okay.
Can't we just subtract, let's say, sine 25? We know sine 25 is in the third quadrant. Can't we just like subtract
Sine 225.
Since we know that 225 is in the third quadrant, and we know in the third quadrant we subtract the angle.
We add
angle.
In the third.
What?
In the third quadrant, we add 180 plus the angle that you have.
Don't you subtract 180 minus theta?
No, in the second, that's where we subtract. And then in the third, where there's tan, you add.
Oh, okay.
Yeah.
All right.
Okay.
Thank you.
All right, you're most welcome. See you in the next lesson.
Okay.